This is problem number 1 for assessment number 9. In this problem, it says Ohm's law for electrical circuits, like the one shown in the figure, states that V equals Ri or IR. In this equation, V is a constant voltage, so we got V as being constant. I is the current in amperes, and R is the resistance in ohms. Your firm has been asked to supply the resistors for a circuit in which V will be 240 volts, and I is to be 15 plus and minus 0.1 amps. In what interval does R have to lie for I to be within 0.1 amps of the value IO equals 15? All right. The first thing we need to do is mark the graph, and then we want to go ahead and mark that this is the current. No, this is the resistance. And this is the current. And they want us to have our current be 15, but with an epsilon of 0.1. So we're going to go ahead and mark 15 here. And remember, 15 is our L value, so we're going to go ahead and mark that up here. L equals 15. And we want our epsilon to be 0.01. No, 0.1. So we're going to say that this part here and part here, this epsilon right here, is 0.1. And the epsilon here is 0.1 as well. So we can essentially be 15.1 or 14.9 for current, and we're okay. So our epsilon value is 0.1. And we're going to be looking for an interval, essentially, for the resistance from one spot to another. Remember, there's like a specific value for resistance that we'd want somewhere in here that I'm sure they have that specified, but we're looking for the interval. Let's go ahead and draw a line here in which the resistance values give you current values that are within this 0.1 value of 15 for the current. So let's label everything we know. We know that L is 15. We know epsilon is 0.1. Because its graph is current versus resistance, we want to, and we're essentially going to be finding resistance values, we want to rearrange this equation V equals IR, or RI in this case, and we want to rearrange it for the resistance. Or actually, I should say we want to be able to find the resistance, so we want to make sure that we rearrange this so that it's I equals V over R. So we're going to divide by R on each side. And that's going to give us I equals V over R. But remember, V in this problem is 240. So we're going to be able to say that our function is going to be I equals 240 over R. Okay. Let's go ahead and start writing out how we find the resistance. So we know that we're going to take f of x minus L, and that's got to be less than epsilon. So we plug in 0.1 and we plug in the 15 and our function, and we get absolute value of 240 over R minus 15 is less than 0.1. Now I always like to use an equal sign and set up my absolute values and then just use the number line to check to see where my solutions lie. So I'm going to start by saying 240 over R minus 15 is equal to 0.1. And then I'll say 240 over R minus 15 equals 0.1, or 240 over R minus 15 equals negative 0.1. We add the 15 for each of those, we get 240 over R equals 15.1, or add the 15 there, we get 240 over R equals 14.9. we can go ahead and flip this into a different fraction. So we'll say r over 240 equals 1 over 15.1. Do the same thing on the right side, so r over 240 equals 1 over 14.9. Multiply the 240, and we get r equals 240 over 15.1. And same thing here, we get r equals 240 over 14.9. Plug in 240 divided by 15.1, and we get 15.894. Do the same thing on this side, and we get 16.107. So this smallest resistance value is 15.894, and this resistance value is 16.107. So we have a interval from 15.894 to 16.107. And that's the solutions for the resistance values. And I should use brackets here on these because those will give you the exact values of 14.9 and 15.1.